Hello everyone. This is a 4-wire fan. It is an industrial standard fan that is used in many desktop computers around the world. Here, we have it wired up to an Arduino with an LCD displaying info about its current status. This entire product is programmed in assembly. To begin, this is the LCD. As you can see, it is displaying the raw reading from the potentiometer, the duty cycle that it is producing, and the theoretical RPM of the fan that it is controlling. Let's take a look at each of these numbers individually. To read from the pot, an analog read is performed. For simplicity, only the 8 most significant bits are taken from the conversion. Now, to display this data on the LCD, we need to somehow extract each decimal digit from this number. For this, we use an algorithm known as dabble. This converts raw binary values into binary coded decimal, or BCD for short. Each digit has a single nibble to store it. These nibbles are then converted into ASCII and then displayed on the LCD. To determine the duty cycle, we need to map the analog reading to a percentage from 0 to 100. Since our analog reading is from 0 to 55, we can divide by 25 to roughly get our percentage. There is no division instruction in assembly, so instead we will do repeated subtraction and count the number of times we repeat the process. Once the number gets below 0, we know we are done. This is the value that we put onto the LCD, after the double algorithm, of course. The final value is the theoretical RPM, and it is very similar to the rest of the LCD output. There is a table in the fan's datasheet that specifies what RPM the fan should output for a range of duty cycles. This, simply, is stored in an array and retrieved from the LCD when it wants to update. The fan itself is controlled using the compare match B pin on timer 2. It is set to mode 7, so when it overflows at OCR1A, it will set the output pin, and whenever it reaches OCR1B, it will clear it. With OCR1A set to 80, and with a prescaler of 8 and a 16 GHz clock, the fan gets the required 25 kHz frequency. By altering OCR1B, the duty cycle, and thus the RPM of the fan, changes. I hope you enjoyed this 4-wire fan. Thanks for watching.